find Andy, find Joe, and able to be connected to the right resources. I don't want to spend much more time talking about myself, so I'm going to hand it over to Jon.
Cool, thanks. All right. Yeah, there we go. Give him a round of applause. That's what I'm talking about. All right. Can you actually see the slide in the camera? You can see it a little bit? Okay. Cool. Well, hey, everybody. Thanks for coming to my talk. I think I know pretty much all of you. So hi, friends. So this is How I Learned to Stop Worrying and Love Vibe Coding, Security Edition. This is a bit of a beta test talk for a talk that I'm giving at B-Sides Pittsburgh. So I am open to feedback if you have any feedback. And I'm very open to questions as we go. So if you think of something and you'd like to ask a question, no need to wait. Just throw your hand up or just interrupt me or throw a tomato or a paper airplane or something like that. And we can talk about it right then. I feel like it's always better to hit it in the moment than wait for the end for questions and answers. And eventually they'll kick us out of here. I think technically we're here until 7, but they can kick us out if we're going a little late. I'm fine to hang around as long as we want. So if we haven't met before, which there might be a small handful of you, I'm Jon Zeolla. I live here in Pittsburgh. That's the most beautiful picture of Pittsburgh. I love the three bridges. I work at a company called Zenable. I am the founder, and we help companies adopt AI coding solutions through Guardrails and things like that. I also own a consulting company called CSA that's also based here in Pittsburgh, which Eric is a member of our team. And I also teach classes. So I teach for SANS, and I specifically teach the SANS Sec 540 Cloud Native Security and DevSecOps Automation class. And so I love cloud native security, and we'll talk all about that in a few minutes. I also teach the newer Sec 545 class, which is the generative AI security class as well. So if you're into the Gen AI world, I would highly recommend checking that class out. It's a 3-day class, and it's like brand new, and we're growing it to 5 days, but it's really a lot of fun. And like I said, I also do open source things. So my background is I spent a lot of time contributing in open source to things like the Apache Software Foundation, to the OpenSSF, and mostly lately I've been working with the Cloud Native Computing Foundation, which is a little hard to read black on black there. But I'm what's called an ambassador. And what that means is I have a lot of stickers. No, so an ambassador, our role, it's a volunteer role. It's one of the many hats I wear. And our goal is to just kind of talk to people about cloud native and help to fix adoption issues. So if you're running Kubernetes clusters or Kubernetes ecosystem things, or you're running a highly scalable application in the cloud and you're running into issues, my job is really to either directly help you or connect you with people that can help you. So you're welcome to reach out to me and I can help you with all of that. But that's also a part of the class that I teach in SANS and a lot of what my day job has been for the last decade or so. And finally, I organize a security conference, so B-Sides Pittsburgh. Who here is going to B-Sides?
I wanted to.
You wanted to, but you can't. All right, well, you can just leave. Now, the door's right there. Yeah, no, it's shaping up to be a great event. Hey, come on in. We're just getting started, so you didn't miss very much. But yeah, so I run a security conference. I run a lot of small projects and an event called Steel City InfoSec, et cetera. Yeah, what happened there? That's weird. It's focused on me. Yeah, hold on one second. Let's see if we can fix this. So this thing, I don't know why it keeps getting turned back on, but that needs to be turned off. And then we can do one of those. Something like that. And we're back. All right. So also, something different about B-Sides this year is that we are raising ticket prices. And so if you buy a ticket after the cutoff for us to print t-shirts, it's going to be like $70-something. So please just don't wait and just buy one now or soon. I think we jump prices on June 14th. So June 13th or before, buy a ticket, come to B-Sides, compete in the CTF, lockpick. We do a bunch of different things. And there's still a surprise. I don't think we've announced the surprise yet, but there's a super cool surprise this year that you should definitely be there for. and that's on June 11th. Another quick shout outs, I was asked to mention the ISC Squared chapter. So if you are not familiar, we've got a few different events in Pittsburgh that have to do with InfoSec. You can go to pitsec.com. Let's go to pitsec.com/events, and you can see a listing of all of the different groups and conferences here in Pittsburgh. But specifically, I was asked to mention this FutureCon, so check it out. I think it's free. Is that what you said, Ryan?
Yeah, it's free. We're looking to get people signed up for this one. We're a partner with it. Can you go back real quick? So if you use, I don't know, just take a screenshot. If you go to that link.
If you go to this link.
No, the one.
No. If you go to this link.
Yeah, and then use that free code.
Yeah.
PGH is free.
Okay.
June 5th. Even if you're not going, honestly, sign up.
So use the free code, and it helps ISC Squared.
Yes.
Yeah. Okay. I like it.
Because we get 10 people signed up that way. It's good for us.
Yeah. All right.
Honestly, it's maybe not. It's a decent conference. I wouldn't compare it to B-sides, but
Yeah.
it's free.
Yeah. I mean, check it out. The more, the merrier, right? Awesome. So cool. Thank you.
Yeah. Go ahead and do that. Everybody get that? Or if you just go to the
ISC Squared Pittsburgh. I think you can Google it. Yeah.
website, just go there. We got everything coming up listed.
Awesome.
B-sides, just go there, sign up, and
Cool.
yeah, we appreciate it.
Awesome. Thanks, Ryan. All right. So let's get into the meat of this talk a little bit. So who here before this talk knew what vibe coding was? Okay. Kind of some yes for another. Who would be willing to take a stab at actually like defining it or describing it? Yeah, Mike.
It's generating your code via AI, mostly.
Generating your code via AI, mostly.
Yeah.
Anyone else want to take a stab at it? Yeah, it's kind of like using AI to generate the code and not really actually reading or evaluating the code manually, but instead using the vibes that it gives off when you run it or when you skim the code, right? And it actually came from Carpathia here. This is the original tweet that kind of kicked everything off. There's this new thing I call vibe coding, where you give into the vibe and you forget that code even exists. You just ask questions, look at the end results, and kind of iterate talking to the AI. And so that's what we're talking about. We're talking about writing code without looking at the code and just doing everything based on the vibe. So how many people here work in like security or cybersecurity? How many people does that freak out? Yeah, okay, about half of the group. All right, cool. So we've got a couple people that are like all in for the vibe coding. I love it. That's great. So this is kind of what kicked things off February 2nd, 2025. Figured that was worth an honorable mention. And a lot of people, they really embraced this. And in fact, I found a couple of good examples. So here's one where Leo said, my SaaS was built with Cursor, 0 handwritten code. AI is no longer an assistant, it's also the builder. Now you can continue to whine about it, or you can start building, right? P.S. Yes, people pay for it. So great, he was able to make an app that people pay for without knowing how to code and just doing pure vibe coding. And then after that, he says, guys, I'm under attack. Ever since I started to share how I'm building my SaaS using Cursor, random things are happening. Maxed out on usage on API keys, people are bypassing the subscription, creating random stuff in the database, et cetera, right? So things are going poorly for him. Most of us probably not super surprised, right? But there's an interesting twist. This is my favorite twist of the whole thing. I just vibe coded my way out of a cyber attack. Ask me anything, or at least I think I did, right? So he's just continuing to double down on this vibe coding. How can I fix the bugs? Can I ask the AI to fix the bugs to prevent the attacks or what have you? And ultimately, it didn't work out. So he did ultimately shut down the application. He said, Cursor just keeps breaking other parts of the code. It can't really keep up. It can't make this thing maintainable. It's just not working, right? And if you look, this was March 19th, so things have gotten better since here. Like, these models are improving, but we still have the same kind of problem today. Right? We have a problem where you can't just ask the AI to do something and be fully confident in its results. It might have unintended side effects. We'll talk a little bit how AI models get trained and why they might have those side effects. I have a funny video for that. Here's another example of a partial kind of success story, right? So Claude 4 just refactored my entire code base. So Claude 4, this is pretty common, like it's pretty new. This happened, I think, within the last week. 25 tool invokes, 3,000 new lines of code, 12 new files. It's modularized everything, broken up the monolith, clearing up the spaghetti. None of it worked, but boy, was it beautiful, right? So yeah, like this is the thing, this is the trick. When you vibe code, when you use AI coding assistants, it's extremely convincing, and it makes really nice, beautiful looking output. And it can kind of pull the wool over your eyes, right? Like it can kind of convince you that this thing is actually good, convince you that you actually had bugs, and it fixed those bugs, when in fact it's injecting mistakes or bugs in your code base. And so this talk is about how do we kind of put guardrails around and understand that this is the case, but still embrace vibe coding. Like how can we still build tools using AI coding assistants? And I'm kind of using, maybe I'm like overusing the term vibe coding. I mean use coding assistants and use them heavily. Use agentic loops to build things and to be able to validate and partially trust the outputs. How do we get outputs to the point where it's useful, right? And so like it made this beautiful looking code on the front end, right? It might even make a nice UI, but ultimately what it really made is something that looks like this, right? Like sometimes it'll even function, right? It will actually work. And the water is going from one pipe into the other, but it's maybe not working the way that you expected it to, right? Like I probably expected it to go down the pipe and then turn at the elbow, and it's kind of just making it through that crack down there, and hopefully negative 9.81 meters per second squared doesn't change, because if gravity changes, this thing's kaput, right? It's just kind of interesting. I wouldn't have expected this to work, but it does. This is what we get when we are vibe coding. And so let's talk a little bit about how these models are trained and how they think, so that we can understand maybe how to put our arms around them and how to anticipate maybe some of their outputs. So hopefully this isn't going to be too loud. Well, I can't control the sound, so you're on your own, people. All right, so this is kind of a non-technical way to think about LLMs and training LLMs. What I found, and I watch videos, I watch a lot of YouTube, and I enjoy watching AI-themed YouTube videos that are both educational and funny. And so this is pretty much my evening watch list that we're gonna see here. Here we've got an example where we're trying to teach a number of different bipedal and quadruped objects walk. And so when you start, things are kind of random, but they're rewarded for moving forward. And so they're moving in this pretty random way, and they get a reward for moving forward, and they're punished for falling over, right? So we told them what's good and we told them what's bad. And so as we go, you'll start to recognize that we are seeing a little bit of progress. So 181 iterations. What we're doing is we inject a bunch of randomness and we feed back into this system what is good and what is bad. Falling over is bad and moving forward is good, and this yellow thing, it's doing pretty good, right? We're pretty happy with that. And then kind of at the end of this learning, it looks like this. Man, that guy can walk. Look at him go. Look at him go. Oh, okay, maybe not. All right, well, hold on. We got to go back to someone else. Or keep going. They're going, right? So it's very interesting. We can see how you can make progress, but it's not exactly the way that you expected it to look. That is not, I don't know about you, that maybe not the most efficient way to make it to the finish line. And now here is another interesting example. So here, what they were trying to do is optimize for speed, and they were trying to see, can we make an AI humanoid run faster than Usain Bolt?
Wait, you're not going to let us know who won that race?
Oh yeah, I'm sorry. I'm not going to let you know. You're going to have to go watch it to find out who won the race, yeah. So when you get to the point where this is kind of starting, you can see, all right, it's kind of making it a little bit. This is after 4 hours of training, but man, check this out. This thing can go fast. There we go. Look at that. It's like a rocket ship. Usain Bolt, 9.58 seconds. That guy, 7.38, right? Check it out. So that didn't work the way that I expected. It didn't look the way I expected it to look, but wow, was the results cool, right? It was fast. And so it's very easy as a developer or a user of AI systems to say, man, did you see how fast that thing was? You use the vibes and just say, look, did you see this, the web UI? Do you see how like reactive it is? Do you see this great graph and visualization? I upload the file, it seems to work. But under the covers, it's kind of hobbling around like that. We're not done yet. Hold on a second. We've got a couple of more examples I got to show you because this is just too funny for me. So let's look at bowling. So what if we had an AI bowl? What would that look like? But look at the results, right? Look at the results. It got a strike. I don't know about you, but I don't get very many strikes. And it makes mistakes too, right? It gets gutter balls, but it also gets strikes, right? And another really good one, table tennis. All right, so let's see how these two things can play table tennis. There we go. There's just a little bit of shakiness. But look, they're playing table tennis. They're going back and forth, and ultimately somebody wins the game, but, you know, not too shabby, right? Not too shabby. There's like 1,000 of these. If you're interested in a slightly more profane twist that has some technical parts, I would look up Code Bullet, but there's a whole bunch of different AI training videos online for things like this, right? So my point there is inject a little humor, number one, and number two, kind of illustrate the point a bit about we might be getting results. It might be able to play table tennis or might be able to bowl, but it's kind of not doing it in the way that we expect necessarily. And the way that this actually works is we are training these models, and it's commonly doing what's called back propagation, right? And so we're tweaking and tuning this high dimensional space gradient, and we're going to, I can kind of show you here, during the training process, I'm going to show this, close that. During the training process, we're trying to optimize, right? So in the prior examples, we were optimizing for walking forward and penalizing for falling over. Here, we're optimizing and we're trying to get the lowest point on this line. And so this is a simple like two-dimensional example. And so you can see if we randomly pick a point on this line and we put it right there, we can figure out its tangent, right? We can see the slope of that point, and then we can move towards a low point, right? So this is called gradient descent, right? And so we're essentially descending the gradient. We're trying to get to the lowest minimum. And you can see that we've settled right there. So for this weight right here, we've settled right there. But if you look closely, it's not actually the lowest point in that line. It's just because of where we started did we end up there. And so we've put balls in a bunch of different places. They're going to have different local minima, right? Based on where you start and how big the jump is when you're training, you might end up in different local minima, which are not the global minima, right? So you're going to end up here, which is pretty good. It's better than up here, but it's not as good as this lower point. And like you might have saw previously, it's not actually two-dimensional. It's going to be multi-dimensional. This is three-dimensional, but it's going to be like 1,000 dimensions or maybe millions of dimensions, right? And so it's a little bit more complicated than this. And they also use technically a technique called stochastic gradient descent, which means that they're not being as specific about following the slope. They're kind of jumping around a little bit and adding randomness. A lot of this system is based off of injecting randomness and then optimizing from there, right? That's why you'll hear multiple different training runs in order to create an LLM, because sometimes it's the way that you train, you backpropagate, and sometimes it's your random settings at the beginning, right? It's the randomness that you are injecting into your system. And so if we think maybe more specifically, let's start to apply this to use cases that matter. We're going to talk about generating code. Maybe I'm going to ask an LLM, to add something, and then the result of that is something that I use, right? We're going to do some sort of math or some sort of logic. Anthropic did, I don't know how easy that is to read, but Anthropic did a bunch of research that they released in March of this year, which is focused around tracing LLM thoughts. And in this case, we've got a question on the left. What is 36 plus 59? So what is 36 plus 59? And in certain scenarios, you could use something called tool calling. Tool calling is where an LLM decides, oh, this matches a tool that I have pre-registered. I'm actually going to return a JSON blob, and that JSON blob is going to tell the client that's calling me. It's going to tell them to, are you good to fix that? You know what I'm talking it's going to return a JSON blob and say, this is not really a great situation for an LLM to solve, can we call this one tool? And it's actually going to integrate with an API, for instance, right? It's actually going to call something else. That's called tool calling. And so in some cases, it might say, oh, this is a math problem. Math problems are great for my calculator tool. So I'm going to return a JSON blob that says, call the tool calculator and pass it these different arguments. Then the tool gets called, and it just does the math. It says 95 is the answer, returns it back to the LLM. LLM's like, cool, and returns it back to the user, right? That's what tool calling would be. But what if it didn't have tool calling or didn't have the LLM? Hit that one on the left of the two red ones? Yeah, that should unlock it. There we go. And then you can, yeah, thank you. It's because I keep raising my hand and then it locks onto me and I just can't stop gesticulating because I'm Italian and it's just what I do, sorry. So we've got tool calling, that's one possible thing that we can do. But what if we didn't have that, how does an LLM think? And you can see that it actually takes two different paths. The top path is approximating, right? It's like, well, I'm not a calculator. But I can generalize some things, 30 minus 70 plus 30 minus 80, and kind of like approximate some things and come up with an answer. And at the bottom, I can try to actually solve the math problem. So you can see that inside of an LLM, it's actually doing multiple things. In parallel, it's trying to solve the math problem, and it's approximating the answer to the math problem. And then it compares the two different paths that it took, finds that they both came to the sum of 95, and then they return that back to the user, right? So this is a really great blog post if you haven't seen it, and a number of research papers that came out of this, tracing the thoughts of a large language model from Anthropic. If you're interested in how these things actually work, I would recommend taking a look at those. Yeah, question?
You said they use JSON, but they use another tool to do the tracing?
Yeah, so the JSON that I was referring to is specific to tool calling. So when you ask an LLM to do something and you've configured it in the system prompt or the instructions to like call a tool when you're doing math, that would be JSON based. They describe in that paper a bunch of different techniques that they did, but I don't remember exactly, so I can't answer. Yeah. Yeah. Question.
Have you heard of the Next.js 0 day that happened a couple of months ago?
The Next.js vulnerability. I'm not sure which one you're referring to now.
So Next.js is a framework that people use to populate websites and apps.
Mm-hmm.
And they had a 0-day vulnerability that if you used it, made your website vulnerable. Do these LLMs use in JavaScript? It would be like frameworks, libraries, stuff like that. And how do you make sure that those libraries don't have 0 days?
Ah, that's a good question. Okay, so your question is, do the LLMs use libraries directly? That might have vulnerabilities, and then how do you prevent that use? So yeah, there's a lot of infrastructure that supports LLMs, right? You have the model itself, but then you've got this like scaffolding or surrounding API infrastructure and things like that to invoke the model, to pass the inputs, the parameters into it, to take the outputs from it, to feed things back into it, because when you're doing inference, you're doing a lot of invocations of the model. And there's like this whole looping process that you have to do. So there's software that wraps around the model. There's the model, the kind of weights and biases that are just kind of in a big bundle. And then you have the infrastructure to facilitate it. And yeah, that infrastructure can have vulnerabilities. It can be configured wrong, like from a business logic perspective. It can have software composition analysis problems, like just dependencies that have CVEs. And you just manage that the same way that you manage anything with infrastructure, like manage regular updates and mitigations and static code analysis, SCA tools, things like that. On top of that, and I'm not sure if this is what you're asking, these tools also, when they generate code for you, they generate it using frameworks that they've been trained on and programming languages as well. And so there are ways that you can kind of guide it to use or to avoid certain types of tools, languages, versions of code, or to use certain types of frameworks, right? And a lot of that you end up doing with prompting, or you can do with fine-tuning, although that would be really inefficient. You typically would do that with prompting. So you would add they used to call it the system prompt. Now it's more called like the instructions to the LLM. It's kind of a meta prompt that's saying like, what are you doing here? You're an expert reviewer, do X, Y, and Z. And you would pass that sort of information in. You know, you prefer these frameworks over those, suggest this library, things like that.
So does vibe coding replace like test-driven development?
Does vibe coding replace TDD? No. And we will talk about that in more detail in a couple of slides. I have a couple specific suggestions. However, vibe coding is great at ruining your TDD as well. So if you have a lot of tests, the AI loves to change the tests just like it changes the code. And so it will inject a bug on your code side, change the tests to make the test pass, and keep things moving so you can ship that bug right to production.
Wouldn't that be less efficient?
Wouldn't that be less efficient? I agree. It is definitely less efficient. There's some ways that you can manage it though, right? We'll talk about that. Good questions. All right, and so the future of AI coding, this comes from a blog post that's very optimistic on the future, but you know, we're kind of here-ish, right? And so we're at this point where vibe coding is kind of popular. We're like right here, right? And so people are doing chat-based programming. That's going to go and kind of start to hit its limits. Vibe coding is going to overtake that, but then really we're going to start moving towards this agentic loops, right? Where we're coding with agents, then we have clusters of agents and entire fleets of clusters of agents writing code and checking. One of the things that I spend a lot of time on is how do I do evaluations of the output of a model. So it does something, how do I know if it was good or not, right? How do I evaluate that output? And interesting enough, one of the best ways to do that is to use another LLM, right? You use an LLM and you create an output. You take that output and shove it to another LLM and you say, what's called LLM as a judge, right? You say, score this on a scale of 1 to 10, score this on a scale of 1 through 100. Is this good or bad? Are there bugs in this? And you ask these different kind of judging questions. And then you get the output of the LLM as a judge, and then you use that output to make some other decision. Maybe we regenerate, we re-ask that initial prompt because whatever the last LLM judge said gave it a failing grade, so we're gonna retry it. Maybe we change and tweak what's called the temperature, which increases the randomness in the system and allows a little bit more creativity and randomness in the outputs, the token creation. How do you know that the judge isn't hallucinating? You don't. You don't. Yeah. You don't. Yeah. So there's a number of different techniques. One of them is called semantic similarity, and so hallucinations occur. A great way to prevent hallucination, there's a whole bunch of different techniques to prevent hallucinations. One of them is called chain of thought, and it's really simple. When you ask the prompt, at the end of it, say, think through this step by step, right? And you are prompting the LLM to think through A, then B, then C, therefore D, and it often will improve the accuracy. This is my favorite technique to reduce hallucinations. Tell it not to. Literally just say, don't hallucinate. It will reduce the hallucinations, right? All you have to say is, don't hallucinate. What other techniques are there? There's multi-shot prompting. So you can give examples of good and bad in your prompt. So you can say, please make me something like this, solve this problem. Here's an example of good, here's an example of bad, here's an example of bad, here's an example of bad. And that will, those multiple examples will help guide it towards a good result that might reduce hallucinations. Another thing that we're going to talk about in a little bit, we're jumping ahead a little bit here, but not too much, is guardrails. And so you can take the output and run arbitrary code against the output of these LLMs, right? And so what's to stop you, like you said earlier, from running tests against the output? So refactor this function, but don't break the function definition, right? Or this class and et cetera. Great, my TDD should still pass at the end of this. That's one way that you can check those sorts of things. But again, tests are I'm talking specifically about unit tests, but unit tests are a very low-level, intricate thing. If I pass you 1 and 1 as the two inputs, do you output 2? If your job is to add, okay, great. Then you've got integration tests where you're integrating different parts of an application. You've got end-to-end tests where that's kind of more like vibe coding, right? Like an end-to-end test of what is the end result of this whole thing. And then above all of that is what I like to call policy as code. And so here we're not saying specifically like the inputs and outputs of this function were good, but I'm trying to say at a general level across this whole repository or maybe my whole code base, this is a design pattern that I agree with. And you start to define bigger picture constructs of what's allowed and what's not allowed, and then you impose that on the outputs of the AI. And I feel like that's really like the panacea here. And if you go back to my background in the cloud native world, I've been working in the cloud native world for a number of years. We used policy as code all the time. As a security engineer working on Kubernetes, policy as code is a pretty common thing. It's just not common in the overall world of development and IT. And I believe pretty strongly that we can bring those concepts over to the world of AI, and that's what I'm actively working on. That's what my startup does. We can bring this idea of policy as code to identify design patterns that are desired and not desired, and then overlay that on top of the AI outputs. And so it's not perfect. It's not as specific as tests, and it's something that you continuously evolve and improve on, but you start with guardrails that are, very wide, and by adding these, you can kind of like push it closer and you still have human review. Like human in the loop is still required. But if you keep kind of squeezing these guardrails to make the road that you expect the code to be on smaller and smaller, you can actually allow them to move faster, allow dev teams to move faster. So I said a whole bunch of stuff there, a little bit of jumping ahead, but that was a really great question. Any other questions while we're on the topic? Yeah, Mike.
Not a question, but more of a comment on the same topic. And I think part of the answer to this question is on your slide there with the agent clusters. And
Yeah.
I found that the more specialized the agent is,
Mm-hmm.
the better the outcome is.
Yeah.
So instead of asking AI to do all this massive amount of work, if you ask
Yeah.
4 agents to do a very specialized piece
Right.
of work and chain them together, you
Exactly.
better
So-
results, not losing it.
So from the crowd, Mike G was saying that if you give LLMs or agents smaller tasks, they have higher accuracy, right? They do a better job. And so what you can do is you can compose them together. You can use these clusters. And in fact, I use a tool called LangChain to do that, where you can have like a graph of different things, and I can take an input, split it up, pass it to a number of different LLMs, or you could call them agents if they're operating autonomously, and then recombine their outputs and do a second task, or judge their outputs and have them regenerate, and then have an output, which might even be a tool call, which might hit an API or run some code or whatever. And so a lot of this comes down to, so there's a lot of hype about like super big context windows, right? And if you're not familiar with a context window, it's like how much stuff can you shove into the LLM all at once? 2 million token context windows. It's kind of like, it's like a party trick a little bit, right? Like you get diminishing returns and reduced accuracy the more that you shove in your context window, like period, right? I don't think anyone would refute that. We're trying to say what the capability of this thing is, where it literally won't just start forgetting other things in the context window. Like that's fine, but your accuracy is gonna dump, right? And so that's exactly like whenever I'm building AI systems, I'm trying to find out what is the smallest discrete unit of work that I need to get done, and how do I get that done and divide things up into these different discrete like units of work and divide them up across agents. And so a lot of the work that I do is kind of already at this level where I've got, I just call them graphs because LangGraph, and I also do a lot of other graph database work. It's just a graph of decisions. It's like a flow chart, right? And that works really well, so I totally agree. The trick is, what are those tasks to break it up in? How do you split them up? How do you judge or evaluate them? How do you combine them back together? And then like, what's the end result? How much autonomy do you actually give this thing? Like, do you let it run the code? Do you let it have access to your secrets? Do you let it give an answer back to a customer? Like there's a line somewhere. Do you give it the PHI or just like anonymized data? Like there's all these different limits that you gotta think about, and it's like, how much do I trust these agents? Well, the smaller the context window, the less work I give it to do, the more accurate the results are typically. It also depends on how it was trained and things like that. But
Are you talking about local run LLMs when you're talking about like vibe coding and stuff like that? Or are you talking about like, what's the chance?
DeepSeek.
DeepSeek
Yeah.
or ChatGPT or
Yeah. So the question is, am I talking about locally run LLMs, or am I talking like LLMs that are available behind an API, like the DeepSeek hosted model? You can run DeepSeek locally, so you can do it in either way. But I'm not ambiguating. I'm not disambiguating those. So it could be locally run. You could be running like a small Gemma model or Phi or Llama or whatever, or you could be running it with Bedrock or Open, Anthropic Claude or whatever, right?
So how do you prevent your employees from disability, if it's cloud-based, how do you prevent your employees from exposing
How do you? So it's like the DLP question, right? Data loss prevention. So if we allow employees to use cloud-hosted LLMs, how do I prevent them from oversharing? Well, it's complicated. And there's no great solution, I don't think. Obviously, so I used to do network security. So we put a firewall up in front of that sucker, right? We block things, we block ports, and then people tunnel them over like DNS or port 443 or whatever, and we're like, crap, and now we have to do a TLS termination. It's like, then we get in this like whack-a-mole game. Like, that sucks too. You can set up proxies, and there's a lot of LLM proxies that are kind of popping up now. Light LLM is one, Kong has an option, there's a bunch of different. And so what you can do is you can say, if you want to use an LLM at this company, here's our proxy. Use it. Go through that thing, and then we will allow the ones that are allowed and disallow the ones that aren't, and maybe we'll do data loss prevention. We'll scan it for PHI on the fly and prevent it. And on top of that, we're only going to allow you to hit LLMs where we have a contract where they won't train on the data that we're giving them, and and they won't retain it, et cetera. And that's a contractual thing. They could break the contract, but you've got business level risk management there. It's not perfect, right? It's definitely not perfect, though. I think that at the same time, you can't constrain users to run all of their LLMs locally because it's just simply not going to work. Like if I had to run all the workloads that I do in the cloud on my computer, the thing would be melted, right? Like it's just, I couldn't do it. It also would take forever, right? I do inference on my laptop because I travel a lot for SANS to teach classes, and I wanted to be able to work on the plane, and I'm cheap. I also didn't want to buy Wi-Fi. Now it's getting pretty much free, but years ago, I had to pay for it, $8, $20, whatever. And so I would just run the models locally. But it was so ridiculously slow, I felt like I couldn't get anything done. I actually ripped all that out and started just running them remotely, and it's so much faster and so much easier, even with really crappy plain Wi-Fi.
Would it be better to set up a private cloud server instead?
So you could run your own server and dispatch things remotely. You'd probably want some sort of a GPU, like a P316X large in AWS or something like that. You could do that. In fact, I've done that before. I had infrastructure as code that would spin up a P316X large, deploy a model onto it. I would remotely connect to it, give it some inference jobs. It would give me the result back in an S3 bucket, and then I would destroy the box, and I would get the results back. That's super cumbersome when you can just hit an API, though. But you could do it. Like if your use case makes sense, it's doable, right? It's absolutely. It just might not make sense. It's all it's a very it depends consulting-y answer, but it depends on the scenario. Personally, I would, if I was at a significant sized company, I would make sure to always have some sort of LLM gateway, point your users to that, put your LLM controls there, just old school proxies, right? Only allow connections to places where you have good contracts, and then you can also centralize the billing and everything too. There's all these business reasons why you want to do that on top. All right, great questions. So timing-wise, yeah, so I think we're good. There's a couple of different ways to do this. So if we're talking about how do I make sure the output of the LLM is what I want it to be, I can put guardrails on it, or I can do evaluations, right? These are the two most common tools at your disposal. The guardrails are online, right? So guardrails are active feedback to the LLM as or right after it's doing the inference, the actual generation of some tokens, and then you feed it back into the LLM somehow. Whereas evaluations are offline, after the fact, or not during inference, and they're evaluating the models themselves, whereas guardrails are looking at the inputs and the outputs. And so I am focused on guardrails personally For things like vibe coding and for enterprises, I think that guardrails make a lot more sense. We really care about the inputs and the outputs. I exclusively work with AI tools. Even I am, other than fine-tuning, I'm not training a model from scratch myself, right? Other than for learning reasons. Like, I'm not going to put that thing into production, right? And so for my use case and for most enterprises, guardrails are going to be the way to go, right? And so when we're doing guardrails, we have what I call the guardrails triad. The three things that we care the most about are correctness, conformance, and visibility, right? I want to make sure that the output is correct, right? Accuracy, precision, metrics like that, right? I want to make sure that it's visible, that I can see what it's doing and how it's working, that we have metrics and observability of the thing when it's running, that we know how fast it is, how up it is, SLOs and SLAs, all of those standard metrics. And then conformance. So conformance is the most arbitrary of these. It's not correctness, because we don't actually know what is correct and what is wrong, incorrect with conformance. We're just saying that it conforms to our expectations. And so your expectations are where that kind of policy as code that we talked about comes into play. We build policy as code to enforce conformance. Yeah?
When you say visibility, are you primarily talking about infrastructural visibility, like classic instrumentation, or do you mean visibility of the semantics that are returned by the LLM? Is it the content?
Yeah, so when I say visibility, am I talking about like the contents, like what's going in and out, the prompts, et cetera, or am I talking about the infrastructure? And I'm talking about both. Now, there's privacy, right? Privacy is like a whole nother part of this, where you might want to redact or not store certain bits of information, but the ability to replay activities that cause negative outcomes, I think, is important, right? And so for certain scenarios, you might want to log the inputs and the outputs, but maybe for your standard use case, you don't. Or maybe you have like a in-memory retention, like a ring buffer, where you just hold the last like 10 gigs of inputs and outputs, and you have pointers to different offsets in there, and if something bad happens, you pull it off and you store it for a bit, and you've kind of got a time window. It's like a race condition, but you've got something. The specific result, like what you build, would depend, but I'm talking about both infrastructure and like on the prompting side, the inputs, the outputs. I'm not talking about like monitoring like the actual weights or anything like that, like of the model, but yeah, good question. And so let's talk about conformance. What does it look like to have an output that conforms to something? Well, there's like a million different examples. I grabbed 3 quick ones because I knew I would be lacking time. And so we're going to go through these really quickly. So let's say this is a tool called ConfTest. This comes from the Open Policy Agent project in the CNCF. So this works on text files. What ConfTest does is it transforms a text file, which is structured in one way, into a text file that is structured as JSON, and then runs what's called a Rego rule against that. And Rego is a specialized policy as code language that looks like this deny message, et cetera. It's really this whole code block, right? And so what we're saying is we're looking at a Docker file, right? And so if we have the AI make me a Docker file, my rule might say that look at the from command, and we're going to identify if the from command is in our deny list. The deny list is up top, that's Nginx. And if it is in the deny list, then it's an unallowed image. So I'm saying, here's my deny list. We don't allow Nginx here, right? Or I can have an allow list. We only allow Nginx here. We only allow Kong here. We only allow, what have you, right? These are your kind of guardrails. What's allowed, what's not allowed. You might not be able to make it as specific as this. This could be really painful. If you implement this in your environment and you say, we're only allowing Nginx from now on, and someone needs to run a Go program or some Python code or whatever in a container, yeah, it's going to be a little tough to do that, right? You're going to have to copy everything in and pretty much wipe it out. You might as well just do from scratch. But you might want to do something from and then check the registry and only allow it to come from your internal registry. Right? If you're making and building containers and storing them, you might want to make sure that they're coming from your internal registry. That means that they went through your processes. Or maybe you have in toto attestations. You have an attestation which says this went through our pipeline and we've cryptographically signed it and we ran a SAS tool against it. We did software composition analysis. And after all that stuff, we made a final policy decision that it was allowed and we cryptographically signed that allow. So if we do all of that, we could pull the in toto attestation and make sure that it's what we expected, that the end result is allowed, that the cryptographic signature is valid, and then allow it forward. Those are ways that you can put gates around the AI. The AI isn't going to know about your internal ECR or ACR registry, right? It's not going to know about your Quay or your Docker Hub or whatever. So you're going to take its output and just start running it in production. Well, no, you might have some guardrails like this. You might have a guardrail like this. So this is a tool called GOS, and it's a little bit long. It's a YAML-based structure. This is saying what, at the end of this, it's kind of like an end-to-end test. At the end, when we run the container, it should be listening on port 22, on IPv4 and IPv6 on port 22, and it should be the SSHD service, and we should have these GIDs and UIDs, whatever it is, right? These are very specific. But you can have these generic roles that if you're listening on port 22, it must be connected to an SSHD process or something like that. Again, this is just an example, whatever your roles are. But what's different about this is that GOS runs when the container is running. The prior tool, ConfTest, looks at the Docker file used to create the image, right? So I like to think of these things as belt and suspenders. Sometimes I look at the code, sometimes I look at the way that it's running. And maybe it's a server. Maybe I use something like Inspec, which comes from the Chef ecosystem. And I remotely connect in and I evaluate SSH again, and we say that it should be configured, it should have an SSHD file, it should be owned in this way, and it should have a certain set of configurations on it, right? We only want certain types of key exchange algorithms to be allowed in our SSHD service. Doesn't matter what it is. You set your own rules. What we're talking about is conformance. We are making ways to check that at the end of the pipeline, it made something that is what you wanted. And we'll talk in a second about what you do when it doesn't make what you wanted. Yeah, question? Is this something that would run the output of the LLM? No, not this. So this one would run on the output of the LLM. These are just generic examples that you can use to assess at different points. So this would happen on the output of the LLM. This would happen if the LLM gave you infrastructure as code and told you to deploy it for the infrastructure of your app. You would use this to assess the infrastructure as code after it's been deployed. There's other tools like ConfTest. You could go back to that, or you can use a tool called Checkoff to assess the actual infrastructure as code. And again, we can go full circle here. The LLMs can help you generate these roles. Big asterisk caution. They suck at it. They really, really suck at, because these are what's called domain-specific languages. These are DSLs. These are not common. This is not SQL. This isn't Python. This isn't Go. This is Rego, right? This is a little bit special, right? There's some grep roles. There's the GOS stuff. And there's tons of hallucinations. It gets really tricky to get this stuff right with LLMs. This is where you're going to end up with a little bit of LLM-assisted, handcrafted policy as code, or you have to go to a vendor or someone to help you generate this policy as code that exclusively focuses on policies. Because these languages are hyper-specialized for a niche that works really well for conformance testing AI outputs. They're just not super popular for the last 10, 20 years, so the LLMs aren't trained on them. Yeah, question? Right. Yeah. So that's a great point. If someone's vibe coding, they're not going to be really doing all that. I mean, I would mostly agree with that. I mean, I vibe code, I write this stuff, but I don't vibe code and ship it to production, right? I write policy as code, I run my policy as code, I manually review all the lines, I get peer review of my stuff as well. So we've got some structure around it, and that's what you still need to do. The human in the loop hasn't gone anywhere. You still need that sort of peer review. And yes, I'm not saying that the vibe coders in general are going to be writing or even knowing about this stuff. What I'm saying is that if you're responsible for making sure that at your company or some people that you're responsible for that are doing vibe coding are being safe and have safe outputs, you can build and do this sort of stuff. You can leverage these sorts of technologies to wrap their experience. Is anyone here familiar with MCP? 2, 3, okay, yeah, 4. So MCP, Model Context Protocol, is a way to hook into the IDE while people are doing this kind of vibe coding experience And that's like my favorite tool in the whole world. I won't have enough time to talk about it today, but I'll cover that in a little bit. But MCP is like super powerful for getting this sort of stuff in the development loop so that the human vibe coding won't even know that it's happening, but the AI is getting feedback from the policy as code tools to do the right thing. And so you are just put the guardrails in place, and the vibe coders just vibe, right? They don't even know that it's happening. Did you have a question, Brian?
So is it possible for the LLM to create policy as code? You say, hey, I'm doing this, it creates a policy.
Is it possible for the LLM to create policy as code? Kind of. I have not had good success with that. I would say somewhere around 5% success rate, right? So it's like pretty freaking bad. But it's not impossible. And what it's better at is if you have a general idea of what you're doing, you can work with the LLM and manually do it. It takes a long time, but you can get it, it can kind of help a little bit. But for the most part, you need some sort of specialized LLMs that have been like fine-tuned or trained on the different DSLs, and you need some sort of infrastructure to kind of match make and find the right one at the time. Like if I want an end result of this container has this from statement, there's like 10 tools that I could use to do that. What's the best one for my scenario right now? Like that is its own decision. And then you need a fine-tuned LLM that can make that output. And then you need to test and validate that output, and so it's tricky. It's not a very accessible thing today. Yeah. And so when you use this LLM as a judge, sometimes it can feel like this. So LLM as a judge can be really helpful, and sometimes it can be like indentation is Python is important, so make sure this is correct. But like it's really not like that. It's more like this. Like you just feel like you're getting peppered with kind of nonsense, obvious comments. Like I get it, I know, like thank you, but like if you've written a line of Python in the world, you know that white space matters, right? You know indentation is important. So they can also be really noisy and really annoying. And so a part of this is like, how do you tune the knobs? And how do you make it so it's not too annoying and it's still telling you the useful stuff? It's not easy. And so we're going to talk about, you can't see, there's a little loading bar at the bottom here that shows how far through the presentation. We're about here. I'm going to talk about some roles that I've made for how I do policy as code. And then we'll talk a little bit about like a roadmap, like how you could get started, what's a good first step, second step, third step. So one of the roles is if you have tests, which you should have tests, that the input data is really important. So if you take events and you process events, you should have lots and lots of different types of events to test against. Do not just mock a bunch of things and say, does 1 equal 1 or assert true at the end of your tests, and expect it to catch anything meaningful when you've got users vibe coding or you're using AI. That is a typo right there. Like I said earlier, the AI will change the code and the tests. So they will still pass your tests. So now you need to have meta monitoring of does this PR change both the tests and the code? That's a different sort of flag, and it needs more interrogation, right? And I can tell you about weeks of my life that have been lost to problems like that. It will update tests to pass because again, think back to the like running person. We trained it to say, to accommodate the user, and I told it to make the tests pass. So it made the freaking tests pass by changing the tests, right? It did exactly what we trained it to do, right? Yeah, question?
Can you just separate the test from the output? So just ask the
Can you separate it?
output the result and then bring in the test?
So can you separate it? Probably not, because you're going to want to, in one code change, update tests and code. Say, for instance, you're doing TDD. I found a bug. The first thing I should do is write a test that exercises the bug and fails. And then I fix the code, and the code now passes because I fixed the bug. Great. I am also touching both sides of it, and that should be changed in one pull request, merge, build, deploy, right? And so in that case, I have to change both sides of it. I'm literally just doing TDD.
Right. What I'm saying is like separate the test so you
Well, you could see that. I mean, so I'm assuming that we're using Git, and that you already have version control, and you can know if things have been touched or changed. If you're not using Git, I think maybe you've added a new rule 1, which is use some sort of version control, because yeah, like that was just implicit. Mm-hmm. I am going to add that to my rules. Thank you. And if you expect something to always be the case, enforce it with code. Right? If you are doing peer review or code review of other people and you expect something to always be the case, ask why you're thinking about that. Like, why isn't that just a red X or a green check in CI? Right? Why isn't that a pre-commit on the developer's laptop? Why isn't this already taken care of? Like, sure, I should remember like, those things can break, but in the 90+ percentile case, why am I thinking about something? If I have a standard, if I can write a sentence that says this is what I expect, I should be able to write policy as code to do it. I feel very strongly about that. Tell me I'm wrong. Let's talk about it afterwards, right? If you've got a tricky scenario, because this is pretty much what I've been doing for the last decade, is write a sentence, now validate that with code. Whatever your arbitrary sentence is, right? We had a meeting and we talked about this. Cool, we can do this with code. We can get transcripts, we can automatically analyze that, did we talk about this topic in there, true, false from an LLM, and then provide evidence output that we talked about it and have a pointer back to the transcripts in the meeting invite, right? Like, I've done it, right? This is doable. It's not easy, but it's doable. Check for the same thing in multiple ways. Again, they're going to fix the tests for the code. So if there's multiple ways to check for it, get creative, right? In software development, there's a thing called mutation testing, right? So you might not want to have statically defined unit tests. You actually might want tests that have randomness in them a little bit and mutate themselves and identify useless tests, first of all, which is really useful, or different angles of existing tests that you might not have thought about previously. Test the same thing in multiple ways. This is also unit test, integration test, end-to-end tests, and then what I call policy as code, kind of bigger picture encompassing everything. And prefer things that aren't super rigid, right? So if you're going to use a regular expression or a grep, you're probably going to get it wrong sometimes, right? You're going to have these unexpected formats or schemas, or people are going to do things in weird orders, or they're going to put something in between it, or they're going to use tabs instead of spaces, and they'll be wrong because spaces are better. But use something that's semantically aware, that kind of parses things down to an abstract syntax tree or an AST, and then assesses the AST. Don't just grep the strings, the code, right? So a tool like OpenGrep or SemGrep is really good for this, where it takes Python code or C# code or Java code, it parses it into an AST, and then it runs your rule against that AST. It's way more powerful. All right, so how do you get started, and then how do you mature with this whole concept? Make sure you've got coverage, right? Make sure you have unit, integration, end-to-end test coverage. Use an LLM if you need to, and just say add tests. Just slam it with add tests, more tests. Have you ever seen those like LLM-generated pictures? It's like, make me a rainbow. Make it more extravagant, make it more extravagant, even more extravagant. I love it. Do that with tests, right? Make it more interesting, more different angles, make more tests, different types of tests, just to keep going with it. Now you can over-test, and you can test too rigidly so that every time you touch a single line of code, you're going to have to change like 50 tests. Yeah, there's a balance here. But you want a lot of coverage is good, but really you want different angles of testing your code. After you've got unit tests, so test coverage is like, we should have been doing this. We should have been doing this for years, right? So if you're not, cool, you can start now. Then we want to distribute common instructions, right? Copilot has a thing called Copilot instructions. Cursor has cursor rules. Windsurf has windsurf rules. There's all of these different IDEs and LLMs have ways to inject common rules. You can do them on a per laptop basis. They're called global rules. Sometimes you can have organizational or repository on repository rules. The bottom line is, just write a sentence which says, we write in PHP. I'm sorry if you write in PHP, but some people still do. So you can say, we write in PHP. Don't use other languages here. If you can use PHP for your task, do it. That's an example of a role or an LLM instruction that you can just do really basic things and put them in your repository and start using them. The simplest form of guardrails is just putting an extra string in the system prompt. And that's what those do. Then automate PR reviews. So, well, first of all, if you're not requiring peer review, you should require it. You should do pull requests or merge requests. Then automate that review. So have some sort of a PR review bot do a quick first pass of the code change, right? Because what's really important for developers is tight feedback loops. So if I write code and open a pull request, I want feedback on it as fast as possible. Getting a pull request bot to do that and be able to iterate on it while that's fresh in my head is really important for quality of the PR, and then still have a human do it as well. But get automated PR reviews in place on top of those common LLM instructions. Now we're kind of really getting somewhere. And then optimize for iteration. This is my hot take. At big organizations, we write governance. We have policies, standards, procedures, and they suck. They are horrible. And the only way to get better is to not throw them all away and rewrite them from scratch, right? That's not what we need to do. We don't need to declare governance bankruptcy. We need to optimize to make them better in lots of fast-moving small chunks. How do I change this sentence from what it was to a new thing and get it approved and deployed and out there and done? Finalized, rubber-stamped, tested, cross-referenced back to our contracts and our organizational requirements, whatever it is. How do I optimize for making changes to my company requirements? Optimize for iteration, because once we start to get into an agentic world, that's all we've got, right? We've got these requirements. These guardrails are going to be really all that we've got to keep us on track. So you need to optimize for iteration. Now things are getting interesting. So this is how you get started, right? Get some test coverage, do basic LLM instructions, get our PR review bot, whatever it is, doesn't matter, and optimize for iteration. This is what I consider the baseline. If you're using AI and LLMs, you should be doing all of these things. Now, how do we mature? How do we go kind of to the next level and really get into like agentic fleets and vibe coding? Take all of the requirements and automatically generate distilled context from it, right? So take your contracts, take your security policies, take product requirements, take the Jira tickets for the thing that you're working on, whatever you've got, and distill it down into context, into requirements. Be able to do that automatically. And if you think back to the last slide, we need to be able to iterate on that stuff too. So this goes in both directions. We're going to use it a lot, so we need to change it a lot, because it might be wrong. It might say that we always need to do something, but we only need to do it for one product, not the other, right? And so we need to change it to say, oh, only for this one product do we need that, not the other one. Start using MCP, right? So MCP is a protocol that allows you to do prompting, knowledge, tool calling, and sampling, right? It allows you to integrate into the developer's IDEs like Cursor, Windsurf, VS Code, Rue, whatever, right? Now you can take that custom context that you just had and you can shove it into your IDE, make it available every time the developer asks it to do something. What we're doing is we're informing the LLM of our requirements. Yeah, question? So when I say context, do I mean the system prompt? Maybe. Not always, though. It depends on how the IDE integrates it, but it might just be a user prompt. But regardless of what it is, it's your custom context, right? Yeah, and so this actually happens inside of your IDE. So you would say, write me a script that says hello world, and it writes me a script that says hello world. And then if I have a role which says always check with my MCP server that enforces my requirements, like this is something that we built at Zenable, right? We have an MCP server. It would literally say like check with Zenable after you make things, and then it calls it and passes it the file and says, does this follow our requirements? And then that's where all that policy as code can be run and enforced. If it fails any of your policy as code, it feeds that back as a string to the LLM in your IDE, and then the LLM can fix it. It's kind of like keep trying until the tests pass, and you tell it how to run your tests. It's the same thing, but you do with policy as code. And then you implement conformance, right? You have policy as code, and it's this meta level. You might have it in your repository. It might be something that just runs in your CI/CD pipelines, but it's outside of your repository, so the LLMs can't touch it. There's a lot of different ways. You could do it as a scanning factory. So I could have something running in Lambdas completely disconnected from your environment, but when you open a pull request, my thing runs and checks the conformance of it, and you have no way to change it. That might be the right way to do it for you. There's all kinds of different ways. But you want to have policy as code to implement this conformance and align what you're doing with your requirements, right? So run that conf test, run GOS, deploy infrastructure as code, and assess it with the chef inspec, whatever it is, right? And I could probably name off like 20 or 30 different super obtuse DSLs that do this sort of thing. There's lots of really interesting techniques out there, but you kind of just find one that works for you and use it. I like to use a lot of Python scripts or shell scripts. Those are the easy ones to get started, and then you can use the DSLs if you need something more complicated. All right, awesome questions as well. Yeah.
Maybe not a question, more of a comment that aligns with your maturity there. I think a good example is like whenever I just started using Cursor, okay, let's write a Python script, and it goes, all right, here's where you embed your API credentials.
Mhm.
And the prompt and the rules you're talking about are don't hardcode credentials.
Yeah.
You can embed that into your prompt for what you're talking about.
Mhm.
Your proxy having that baseline rule all is checked. But once I said, okay, I don't want credentials in here, it went back and said, okay, here's a netrc file. No, I don't want to do it that way. Let's always call
Mm-hmm.
false or
Yep.
something like that. That could be
Yeah.
the case.
Exactly, yeah. So the comment is you could have things that just like a rule or an instruction that says never hard code credentials. Like that's a very good example of this. Common LLM instructions that you just always want to be true. You're not special. That's literally everybody in the whole world. You shouldn't hard code credentials, right? So this is just common LLM instructions that you could just inform your developers to put in their rules, or you could distribute it centrally. If you can put a file on their computer, you can inject these rules in like some different global directories. And say never hard code credentials, or like you said, don't use a netrc file or an mvrc file. We're going to pull things from Vault and kind of force things down that path. Or we don't use make files, we use task files here, and like even like little just like engineering standards that are completely not functional. Make files are totally fine. Task files are better in my opinion. But like if that's just the way you do things, put it in there. We use task files. We organize our directory structure like this. Anything that you want, shove them in there. I totally agree. Was there, yeah, another question?
Yeah, wouldn't you just want to set up a linter just to catch a lot of these basic rules anyways? Because like that's
Yeah.
like I write Dell, I got the linter run after code gets generated, writes all the comments and everything.
Yeah.
It creates
Yeah.
API keys, things like that. And the linter points those things out most of the time. So I'm kind of curious.
Yep.
If it's the same practice you had, 5 years ago versus now you're supplying the rules.
Yeah. No, that's a great point. So the point is, wouldn't you just use a linter for this? Like that, isn't that what linters do? And they do, but they kind of fall into this, this bucket of specific structure tests, right? They're more like a regex or a grep. So you can, as far as you can go with linters, use them. They're great, right? But they have limitations, right? And in fact, you probably noticed that if you're using a cursor, that it automatically lints as it generates code. So now it'll generate code and lint it and then fix the linter automatically, right? It's not always the linter that I use, so I have to rechange it, but that's fine, right? We're like iteratively getting better. And so that stuff that's like table stakes, and that's like the basic rules here. Like, yes, you should have linters. Linters are like a naive version of tests, right? And it just like reformats the code to follow your patterns, or to not make the lines too long, or to use snake case or camel case or whatever you do. But they're going to have their limitations too. And so you're going to have to replace those with something more versatile, like a semgrep, or even more like big picture, like policy as code or something like that. But it's a great place to start. I totally agree. All right. Any other questions? Cool stuff. So if you enjoyed the talk, and if you have any crap to give me about anything that I said, I'm all for it. If you want to talk more about this stuff, I'm going to hang around. That QR code is definitely not malicious, I promise. It's just going to go to my LinkedIn, or you can just like connect with me on LinkedIn. That's the easiest way to get a hold of me. I do have an email. I probably am not going to see your email if you send me one. So send me a message on LinkedIn if you want to talk about this stuff ever. Would love to. So thanks, everyone.